Okay, so we're gonna continue today's lesson and talk about parallel and perpendicular lines in geometry. So we've already talked a little bit about parallel lines and um, the relationship between angles when they're cut by a transversal, if you remember that. But we can also talk simply about the equations of lines that will be parallel. So if we were graphing something on the coordinate plane, if I have a line that looks like this, and there's a certain, maybe it's like y equals 2x plus 4, there are an infinite number of lines that are also parallel to that same line, and they have a distinguishing feature. Before we talk about that distinguishing feature, we should also talk really quickly. I didn't realize, but number 5 and 6 on the homework you probably did yesterday, which is the slope and graphing lines worksheet. It's the homework from day 2 in the email. It will probably be easier after this lesson. So if you want to take a look back at that after you look at this video for these sets of notes, it'll probably be a lot easier. It's having you find slopes and then tell whether or not they're perpendicular or parallel or neither. That'll be a lot easier after we talk about this. Just a second. Okay, so parallel lines that we just talked about, there's an infinite number that would be parallel, and they would all have something in common, which is their slope. So if this line was y equals 2x plus 4, this line might be y equals 2x minus 1, and this one might be y equals 2x minus 3. And so on and so forth. So the quality of parallel lines is that their slopes are equal. So the slope of a line parallel to this line, y equals 7x plus 4, the slope, which we represent by m, would also be 7. So that's a pretty simple problem. Conversely, there would be an infinite number of perpendicular lines to these as well, and they would have the exact opposite reciprocal slopes. And what opposite reciprocal means, so slopes of perpendicular lines are opposite reciprocal, and this means, opposite means different sign. In other words, if it's positive, it will be negative. And then reciprocal means flip the fraction, or make it a fraction and then flip it if necessary. So for example, what is the slope of a line perpendicular to the line y equals 3/4 x plus 2? Well, the slope of this line is 3/4. So if we wanted to make one parallel to this line, it would also be 3/4. But if we want a perpendicular slope, the slope that's perpendicular would be opposite in sign. That's the opposite part of the reciprocal. So it would be negative. And then we'd also flip the fraction, so it would be negative 4/3. All right, let's try a couple more examples using these concepts. Looking at the next example, they're just telling you a slope. So if the slope of some line is 2/7, what is the parallel slope? Well, it'll be exactly the same, so it'll be 2/7. And the perpendicular slope will be the opposite reciprocal, so we'll flip and change the sign, negative 7/2. So if the slope is 1, then what is the perpendicular slope? Well, this is a positive one, so we know the perpendicular slope is going to be negative. And then how can we flip this? Well, we'll make it a fraction first, so that would be negative 1/1. If we flip that, yes, it will still be negative 1/1 or negative 1. And if you think about how those lines would look, if we had a coordinate grid, a slope of 1 will look something like this, up 1/1, up 1/1. The exact perpendicular one to that will look something like this if it made a perpendicular. And you can't really see it from here, but it'll be down 1/1 or negative 1. So down 1/1, down 1/1, down 1/1. Yeah, okay. let's look at the last example here before we talk about vertical lines and horizontal lines. So our y equals 1/2 x plus 4, that line, and y equals negative 2x plus 6 parallel, perpendicular, or neither. So when you have a question like this, you're focusing on the slopes and how they compare. So the first line has a slope of 1/2, and the second line has a slope of negative 2. If I look at those carefully, I might notice that they're definitely not parallel because they're not the same. But if I were to take this first one and make it the opposite reciprocal, indeed it would be negative 2. So these two lines are perpendicular. Okay. So that's the basic things you need to know about parallel and perpendicular lines. The exception to this is when we talk about vertical lines and horizontal lines. So if you remember, vertical lines are going straight up. They have what we call an undefined slope. Because remember, the little man cannot climb. He would have to rock climb or something up the cliff. And then horizontal lines have a slope of 0. And they're just flat. And these are actually perpendicular to each other. So if you have an undefined slope, then the perpendicular slope would be 0. And then vice versa. So if you had a slope of 0, the perpendicular one would be vertical or undefined. The other way you can think about that is if I tell you that a slope is 0 and I want the perpendicular slope, if I were to try to make this a fraction, which I could, and then I tried to make the opposite reciprocal, I would get negative 1 over 0, and uh-oh, that is not good. In math, we can never have 0 as a denominator because it's not possible to have 0 parts of something and then have negative 1 of those. It's just not possible. So that in math would be a no-no, and we could know then that that would be undefined. Okay, let's do a couple more examples and I'll set you free for today. Make sure if you haven't already, you watch the other video that goes with this lesson, which is writing equations of lines. So write the equation of a line through the point 1, 1 and parallel to this other line, y equals negative 2x plus 4. So this is a different line. So if we were to graph negative 2x plus 4, this is a sketch of the graph, it would be up 4, and then it would be down 2 over 1. So it might look something like this. I'm not doing a very good job of sketching it, but it's going to look something like that. So it has a negative slope, and then we want a different line that goes through the point 1, 1. That would be like down here more. So it's going to be parallel to it, but a different line. And we're going to steal a slope from this line. So if it's parallel, we know that these two lines will have the same slope of negative 2. So if you remember back from the previous video, which was writing equations of lines, if we're given a slope, we know the slope, and we're given a point, we can write an equation in point slope form, which if you remember is y minus y1 equals mx minus x1. We just plug in here, so negative 2 is going to go in for our slope because it's parallel. We get y minus 1 equals negative 2 x minus 1. And that is perfectly acceptable to answer with that equation. If you really wanted to, you could convert it to slope-intercept, but since we're not graphing it, it's really not necessary. All right, and then let's try a perpendicular one. So in this case, we want to write the equation of a line through this point perpendicular to another line, y equals 4x plus 2. So I'm going to sketch that out for us really quick. That would be negative 2, maybe somewhere down here, and it would be up 4 over 1, so it's going to be a pretty steep line. It might look something like this. We want the perpendicular line to this through the point y equal, through the point 8, 9, which is going to be like way over here. So it's probably going to be somewhere over here. And I didn't make that long enough, but let's assume it's down here actually. It's going to be directly perpendicular to this. So what we need to do is grab the slope from this line and use the opposite reciprocal to write the equation of our line that's perpendicular. So we want to write the perpendicular line equation. Okay, so first things first, the slope of my perpendicular line is going to be the opposite reciprocal of 4, which will be negative 1/4. And then I have now the slope and a point, so I'm going to do the same thing as above and use point slope form, or y minus 9 equals negative 1/4 x minus 8. And that's the perfectly acceptable. You don't have to do anything else to it unless you're graphing, in which case you want to put it in slope intercept. And that is it for today.